Lesson 8.1 was exponential functions, right? So then lesson 8.2 is kind of connecting lesson 8.1 with what we're about to do. So basically, we're going to be talking about the inverse of an exponential function, right? So we know how the inverse of an x squared is a square root. And then we did inverse functions a while back ago, right? Where we just switch whatever. Okay. So the inverse of an exponential is a logarithmic function, okay? So a logarithmic function is the inverse function of an exponential function, which I just said, and most commonly used to isolate the unknown exponent of an exponential function, okay? So for example, if you have 12 equals 3 to the power of what? So if you don't know what the exponent is, you need logs in order to figure that out, okay? So that's why we have logarithmic functions. Honestly, logarithmic functions were created because, you know, kind of like back in the day before we had calculators. So logs were used to express really big numbers, okay? We don't really need them as much, in my opinion, anymore, right? Because we have calculators, but they're still really important when you're, you know, software engineering or programming, anything like that. You still need these functions to create like the technology we use, right? So it's still used. We just don't physically use it the way they did back in the day. So it's still important, but whatever. Okay. All right. So we have an exponential on the left, y equals a to the power of x, right? And then this is equivalent to x equals log base a of y. I didn't kick you out. It keeps doing it. I don't know. It's not my fault. Okay. So I have a story that will hopefully help you remember where this goes, right? Okay, so first let's look at where it goes. So you see that y? Here, let me highlight. Here's y, right? When you convert it to a log, where does the y go? The y is over here, right? So whatever number is on that side of the equal sign is always going to go next to the log. Then your base a is always going to be your little base, right, next to the log. And then whatever your exponent is, that's always going to be what comes to the equal sign because that's your unknown, right? Okay, so here's my story. Pretend that you are A, right? So you're the person. So A is a person now, right? Don't you get tired of just like carrying the weight of your shoulders, right? So that's your ex, right? Or you can even look at it as your ex, right? Someone you broke up with. Either way, let's do the breakup one, okay? So your ex is just like, oh my God, you're so annoying, you know? So what are you gonna do? You're gonna throw your ex over to the other side, right? So do you see how it was on the shoulder of A and you threw it to the other side of the equal sign? You're so tired of dealing with your ex that you're gonna go chill by the log. Y'all see that? You see how the A is now chilling by the log? Acostado, right? So you're chilling by the log, and then now that you're there chilling, then someone else comes into your life and they're gonna support you and stand next to you and not weigh you down the way your ex was on your shoulder. Oh my God, wasn't that a cute story? Tell me y'all thought that was a cute story. Okay, so basically here's what you need to remember. Your exponent gets thrown to the other side. Once you get rid of your exponent, you're chilling. So you're gonna go lay down by the log, right? So log, you're the base now. And then what was on the equal sign is now going to be that number next to log that you're chilling by. Okay. Anyway, so basically that's just something you have to memorize. Okay. You just have to memorize what goes where. Okay. So I highlighted things to help you, you know, color coordinate there. So example 1, convert the following to logarithmic equations. Okay. So if we go by our logic, right, here's my base A, right? You're tired of your x, so you're going to throw it to the other side. So there's your x on the other side. You're tired, so you're going to lay down by the log. So base 3, you're going to go chill by the log. And then the number that's left, right, which was the number on the other side, that's going to come and chill next to you. because you got rid of your X, so they're just gonna slide into your DMs, you know? There you go. Ta-da! That's converted into logarithmic. So that's all I want right now. That's what we need to practice. Before we can solve these, because yes, you will have to solve them. Before we can solve them, you have to know how to convert them, right? Maybe I should write that a little bigger. I have all this room and I didn't even need all that room. Let me write it bigger. Log base 3 of 81 equals X. So this is converted into logarithmic form. That's it. That's all we're doing right now for A, B, C, and D. So can y'all do B? I'm gonna give you a few seconds, write it in log form. All right, so we have our base, right? Whatever your exponent is, you're gonna chunk it to the other side. So you're gonna have a -2 here. Or why am I trying to squeeze it in when I can just, I don't need to. Sorry, I keep trying to squeeze it in when I don't have to. Okay, so we're gonna put the -2 here, right? There's my equals. Your base, now that it got rid of that weight that was hanging on, they're gonna go chill by the log. So log base 10. And then this number that was on the other side is gonna come over here. So 0.01. So log base 10 of 0.01 is equal to -2. That's it, you're done. That's all I want you to do right now. Did anyone get that right? The 10 is your base. Yeah. So try C. Good job. All right, go try C now. I'm gonna give you, okay, so for C, remember, you're the base, right? So whatever you're carrying, so your exponent, you're gonna throw it to the other side of the equal sign. So this -3 is now gonna go there. And you're going to equal the log and that base, you're now gonna chill by the log because you're so tired of hanging on to that exponent, you're done, you wanna go chill. So you're gonna go chill by the log. And then the number that was on the other side is gonna come accompany you right here. So log base of X, 64 equals -3. Basically, yeah. You just have to know where to put them because it does matter. So, yeah. So the base is still the base, right? It's base in the exponent and it's the base in the log. The only difference is it looks a little different. Okay. How many of us got that right? Okay, I'll do the last one now, D. So for D, same thing. The difference is that your base is now a fraction. That doesn't matter, okay? So the exponent in this thing is a -3. So this is gonna come to the other side. So -3 goes here. Your log, you're gonna be the base at the log because you're chilling. And then whatever this number is going to come here. So 216 over 125. Ta-da, you're done. How many of us got that right? Yeah, not that hard, right? Once you figure out where the numbers go, it's not that bad. Okay, good. What about at home? Y'all ain't, except a few of you are telling me. Where the rest of y'all at? Like, what about people at home? Are y'all getting it right? Thank you, thank you. I need feedback, you guys, okay? Y'all know this by now. Thank you. Thumbs up is perfect. I can do thumbs up. I got all of them. Good. See, I need to know these things. Okay, thank you. All right, so example 2. Convert the following to exponential equations. So all we're gonna do is go in reverse, right? So whoever you swapped place last time, now you're just gonna go in reverse, right? So we know that this is our base, right? You're chilling. You can't chill no more. You have to go get back to work. So this 6 is going to take the X back, unfortunately. And then the 36 is gonna come over here. So 6 to the power of X equals 36. Ta-da, that's it. So whoever's chilling by the log, that's your base, right? And then the number that got thrown is gonna come back. And then the number that was by your side is gonna go back to the other side. So you're just reversing everything. So you just have to be able to go back and forth. I don't have a story for this one. I guess you were chilling by the log and then your ex begged for you back and they said they were gonna change. So you're like, okay, fine, I'll take you back. So then you had to, you know, whoever was standing by your side that was a solid person, now you had to throw them back to the other side because you took your ex back. There you go. There's my story. I don't know. Okay. Stories help, okay? They help me. Whatever. Don't hate. Appreciate it. Okay, cool. Go do B. So here we have log base B of 32 is equal to -5. So my base is B, so I know that's going to be my base. It's still called a base, so it's still your base, right? So whatever's on the other side is going to come and be your exponent equals, and then here's your 32. Okay, cool. All right, so there's that. Okay, so C, go on ahead and do C and D. I'll give you like a minute for both. Go on ahead and do C and D. Now you're converting it back into exponential form, C and D. Okay, so for C, your base is 10, right? So you're gonna make this into a big 10. Whatever's on the other side is going to turn into your exponent and then equals whatever this number is, right? So 1,000. So 10 to the power of 3 is 1,000. Ta-da, there you go. Okay. D, same thing. Here's your base. Whatever's on the other side is your exponent. So square root of 7 to the power of y is equal to 49. Ta-da, you're done. There you go. Okay, how many of us got that right? Yes? Okay, good. See, not so bad, right? Okay, good. All right. Now, so really that was the first thing, okay? So the first thing is being able to convert back and forth, okay? Because you're gonna need that when you're solving for x, if it's exponential, or even if you're solving for a logarithmic function, sometimes it's easier to convert it to an exponential, right? So you really have to look at your problem and figure out which one do you want? Do you want it in exponential form or do you want it in logarithmic form? Okay. So common and natural logarithm, okay? So there's the common logarithm, which is log x equals y, which is exactly what we did. And then there's natural logarithm, which really the only difference is that it has that e. That e is a number that happens in natural life where, I really don't know. I know where pi comes from, right? It's like the diameter and the circumference and blah, 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 right? So that number comes from somewhere. Honestly, I don't know where E comes from. I know it's a natural number and it occurs naturally in the wild. I'm gonna go look into that. I feel like I should know this, but I don't. At least I'm honest, right? Okay, I'm gonna go look into it. I don't know. I'm gonna go see what E represents because I've never really thought about it. Okay. Anyway, so you're gonna notice that if it's a natural logarithm, your base is always E. That's really all that means, right? So do you see how with the examples that we did right now, they all had different bases, right? So then you would automatically convert them to logarithms, log, okay? But if they're giving you ln, then your base is E. That's really it. So instead of that number, you see how there's no number down here, right? Do you see how there's not a number and how there's not a number there? So if you're missing a number, we have 10 minutes, right? Yeah, if you're missing a number from the log, this is natural base 10, right? Do you see how there's a 10 there? So if you're missing a number from log, that's really base 10. It's given, it's automatic. Why is it base 10? Oh my God, good question. The reason it's naturally base 10 is because that's our counting system, right? Y'all do understand that our counting system is based off of 10, right? Every time you get units of 10, you move on to the next unit, right? If you have 10 ones, what do you move? You have 1 10. If you have 10 tens, you have 100, right? We go in groups of 10. So that's why if nothing is there, it's automatically a 10 because that's what we use normally. Got that? Okay, cool. All right. So example 3, evaluate the following. So first of all, what do you notice? What are you going to have to do with A? Well, you have to convert it to exponential, right? Because I want to know basically what here, because I said evaluate, I want to know what is this equal to. So because my base is 7, I know I can convert it to exponential. So 7, essentially this question mark is technically x, right? So 7 to the power of what is equal to 49? Who knows? Who knows? 7 to what power is 49? 2. So what is your x? So when you evaluate the logarithmic base 7 of 49, your answer is 2. But do you see how when we converted it to an exponential, it was a lot easier to evaluate? Okay, go do B. Okay, so we had a question, right? So, okay, let's do another example. So log, so there's not a base here, right? Which is what we talked about out here in common logarithm. Because there's not a base, this is an automatically base 10. So you can automatically fill that in every single time. If they don't give you a number, then it's automatically 10. So you want to know, what does this equal? So let's give it a different variable, m, because it doesn't matter, right? So you want to know what does this equal? So you're going to convert it. So 10 to the power of m equals 100. So 10 to what power is 100? 2. I made them easy, okay? Because I wanted y'all to get the point of it. So 2, right? So your m here would be equal to 2. So when you evaluate the log base 10 of 100, it's 2. But it was easier to see what your answer was when we converted it to an exponential. But your calculator does do logs also, I think. I think it only does natural logs, common logs, I mean. I don't know, I didn't look into the whole calculator thing because today was supposed to be an easy thing. Because it's like the first time you've ever seen it, right? So I'm not gonna like throw crazy stuff at you. Okay. Now, for this next one, so ln1, it's kind of like a special property, but we're not doing special properties yet. So for this example, C, right? So natural log, it's a property, so I don't really know how to explain it. So I'm just going to tell you that anytime you have ln1, it's always going to be equal to 0. Yeah. Yeah. You know how like, you know how when we have laws of exponents and any base to the power of 0 is 1, and we're just like, it's just a property, it is what it is. You know what I mean? So that's why I put them on here, because it just is. Okay, it just, yeah, it just is. I'll figure out a better way to explain that, but it just is, like, you know, what you want me to do? So ln E is another one of those properties. These properties are going to be given to you again in another lesson. I'm not making it someone else's, but they're going to give these to you again. But I'm like, you know what? Might as well give them to you now so you can get used to them, right? So another property, ln E, is 1. I know. Yeah. Yeah, that's it for 8.2. Any questions, comments, or concerns? See, I told you that was a short lesson. Hold on, how can I explain this better? Now, because now I feel like I should. Hold on. E, because this is really e to the power of what is equal to 1. Oh, I guess that's not that hard to explain. Give me time. It's not that hard. Okay, look, y'all watch out. Watch out. Yeah, we just did them right now. Yeah, we did. Okay, so for C, right, because it's in natural logarithmic, we know we're going to use this. So ln x equals y, which is the same as base e. So we know this is base e. So e to the power of whatever this number is. So we don't know what that number was yet, right? So m equals, and then this number goes here, 1. So any base to what power is 1? This is the laws of exponents, right? So from, what lesson was that? I don't know, some lesson from back in the day, right? Any base to the power of 0 is 1, right? So that's why your answer is 0. So e to the power of 0 is 1. This is 0 exponent law. Okay, so the same thing happens here, right? So we have ln. So we know that our natural log is, or our natural base is e, right? So e to the power of 1, or what, which we know is 1, is e, right? So in order for it to be itself, the exponent has to be 1. So that's why we get 1. So those are really just properties, and you can just know that. ln 1 is always 0, and ln e is always 1. Ta-da! Okay.